So we've just finished studying this situation where we have two parallel lines cut by transversal. And we looked at postulates, theorems, but it was always if you have parallel lines cut by transversal, then this. Now we're going to go the other way. We're going to look at the converse. Remember, we had this corresponding angles postulate that said if two parallel lines are cut by transversal, then the corresponding angles are congruent. Now we're going to say this. If the corresponding angles are congruent, then the lines are parallel. In other words, if two lines are cut by transversal so that the corresponding angles are congruent, then the lines are parallel. So and that really makes sense if you think about it. Think about a couple of parallel lines, and they're cut by transversal. Now, obviously, these angles, this angle and this angle, they're congruent. This angle and this angle, they're congruent. However, that's because these lines are parallel. But look what happens if I just make one of them not parallel. Notice how that angle changes. Notice how this angle over here changes. Okay? So the two lines have to be parallel. Now there are some other theorems here for the converses. Alternate interior angle converse that says if two lines are cut by transversal so that the alternate interior angles are congruent, then the lines are parallel. And you've got several of these. You can read those yourself. So I want to get right into, so what we're trying to do is we're trying to show that lines are parallel. Before we were assuming the lines were parallel. Now we're trying to show that they're parallel. So let's look here. Let's just see how we would prove this first one. Theorem 3.8. Okay. So we want to prove, so we've got this situation where M and N are lines and they're cut by transversal. We want to, such that angle 1 is congruent to angle 2, as you can see in the diagram. We want to prove that the lines are parallel. Okay, so let's see here. We got our statement, and we get our reason. Okay, now first of all, we know that angle 1 is congruent to angle 2 because that's given. Yeah. Now we also know this, that angle 2 is congruent to angle 3. And the reason we know that is because they're vertical angles. Okay, now that we know that angle 1 is congruent to angle 3. And that's by the transitory property. Remember, if angle 2 is congruent to angle 1, and angle 2 is also congruent to angle 3, then angle 1 is congruent to angle 3. Now, notice that, so this is where we are now. Angle 1 is congruent to angle 3. Now, angle 1 and angle 3 are corresponding angles. Okay? By definition. Therefore, N is parallel to M by the corresponding angles converse postulate. So I'll just say corresponding angles converse postulate. I'll do it like that. Yeah. So there, we've proven that first one. So notice the way you start. You always start with what's given, and then you look for ways to build on that. Okay, based on what's given, what else do I know? Well, one of the things I know is angle 2 and 3 are congruent. See, because when we started this, the game we were playing, we wanted to use this one right here. We wanted to use that postulate. Okay? In other words, I need to know something about this angle. If I know that angle 3 and angle 1 are congruent, well, that's that postulate. So I worked toward that. I said, well, angle 2 and angle 3 are congruent. And since angle 1 is congruent to angle 2, angle 1 is congruent to angle 3. So it worked out that way. So that's the way you think through this. Now, next we want to prove this. Prove the consecutive interior angles converse. Okay, the consecutive interior angles converse. Now, remember the consecutive interior angles converse. If two lines are cut by transversals so that consecutive interior angles are supplementary, then the lines are parallel. So this is what we're trying to prove over here. Then the lines are parallel. Okay, so here we go. Angle 4 and angle 5 are supplementary. Okay, so let's start here. We got a statement, and we've got a reason. Okay, so first of all, angle 4 and angle 5 are supplementary, and that's given. So that's always the first step. Now, look what we're trying to do. Angle 5 and angle 6 are supplementary. Okay? And there's a couple of ways you could a couple of reasons you could give for that. I'll just say that they're linear pairs. Okay, because angle 6 and angle 5 are linear pairs. Now there are other ways we could go about that. Now look what we have. We have 4 and 5 are supplementary. Okay, 4 and 5 are supplementary. And 5 and 6 are supplementary. Okay. Therefore, now notice, measure of angle 4 plus the measure of angle 5 adds up to 180. Okay, the measure of angle 5 plus the measure of angle 6 adds up to 180. Therefore, look what we have here. Angle 4 and angle 6 are supplementary. Okay? And I didn't give myself room down here. Let me move this down. Okay? Because angles supplementary to the same angle are supplements of each other. Okay? So, because that makes sense. If the measure of angle 4 plus the measure of angle 5 is 180, and the measure of angle 5 plus the measure of angle 6 is 180, then the measure of angle 4 plus the measure of angle 6 must be 180. So this is angles, I'll just say supplements to the same angle are supplements of each other. Now, there's a name for that theorem, but you don't have to get bogged down in these names. And you see how this goes all the time. I mean, you see how these proofs are set up. Okay? Now, okay, so there's what I want to do is I'm trying to show you just real simple proofs, and it takes a while. You have to be patient. These take a while to get to where you can kind of work your way through. And we're not being real formal with these. So, but anyway, we're just trying to learn the concept. Now let's look at some of the non-proof things that we'll do with this section. It asks this question, is EB, the ray EB, parallel to HD? In other words, here you have EB, and we want to know if that's parallel to HD. Well, you could think of these, you could extend this line out, and then you can see you have lines cut by this transversal right here. Well, then these corresponding angles need to be congruent. And they're not. Look, this is 58 degrees and this is 61 degrees. Okay? Therefore, those lines are not parallel. We could tell if they're parallel if the corresponding angles are congruent. So look, here's the thing. So we'll look at part A. The measure of angle, what is it? BEH is 58 degrees. And the measure of angle, let's see what this other one is. DHG is 61 degrees. Therefore, they're not parallel, because these angles have to be the same. Now let's look at the other one here. We've got EA, okay? So let me look at EA, okay? Get a different color, okay? EA, okay? So here's EA, and I'm wondering if that's parallel to HC. Okay, well, it's parallel if these angles are congruent. So look, we've got 62 plus 58. That's 120 degrees, okay? And then we've got 61 plus 59. And that's 120. This angle is 120 and this angle is 120. So yes, these two lines are parallel because these two angles are the same. The corresponding angles are the same. Okay, now look at the types of problems that you'll be working in the assignment. Okay, so you've got find the value of x that makes R and S parallel. Well, look at this first one. You know that 2x, the 2x and x, those have to add up to 180 because these are supplementary. Okay? So you have to say 2x plus x is equal to 180. Okay? Over here, you have 90 minus x degrees, and down here, x. Okay, so you have these two. Well, those have to be equal. But anyway, you see, I don't want to give it all away, but you just use the properties that you know. You know that these have to be supplemental, and you know how it is with parallel lines cut by transversal. Remember, you've got parallel lines cut by transversal. This is equal to this, this, and this, and then these are equal, like that. Yeah. So, I mean, what you don't want to do is you don't want to, try to get it in your mind. Obviously, they're either going to be supplementary or they're going to be equal. So you can see that these are clearly not equal, so they would be supplementary. And remember the two things. Well, I don't need to go into it again, but okay. Now down here, this is a problem like we worked up here, okay? And then you've got a proof. So there you go.